Hi, we're going to talk about another form of factoring. It's a little bit easier, maybe, or maybe it's harder. It's called special products, and this special product is called the difference of two squares. Remember back in chapter 4, back in one of the previous modules, when you learned about multiplying polynomials, we multiplied conjugates. These are conjugates. When you multiply conjugates, you get this. When you multiply this, you get two conjugates. So notice that x squared minus 16 equals x plus 4 times x minus 4. 4 is the square root of 16. X is the square root of x squared. Now let's look at 25x squared minus 81. Both of these are perfect squares, and look what they factor into. 5x plus 9, 5x minus 9. Now 5x is the square root of 25x squared, and 9 is the square root of 81. Now here's a tricky one coming up. X to the fourth minus 16. X to the fourth is a perfect square. The square root of x to the fourth is x squared. And the square root of 16 is 4, so we can actually factor this by the difference of two squares and get x squared plus 4 and x squared minus 4. But look, x squared minus 4 can be factored by the difference of two squares. The square root of x squared is x, and the square root of 4 is 2. So the complete answer to this, the factorization of x to the fourth minus 16, would be x squared plus 4 times x squared plus, times x plus 2 times x minus 2. Let me read that again. X squared plus 4 times x plus 2 times x minus 2. Well, why don't we factor this? And here's the answer. Warning! If you have the sum of two squares, that is, if you have a squared plus b squared, that is not factorable. So x squared plus 4 is not factorable because of the plus sign. X squared minus 4 is factorable because of the minus sign. Look at x squared plus 16. X squared plus 16 is not factorable. It cannot be factored. Even though x squared minus 16 can be factored. X squared minus 16 can be factored, but x squared plus 16 cannot be factored. So this is factoring by the difference of two squares.